Hi, I'm Jack Bowman, and today I'm going to be talking about FRQ 2013 Question 1. Part A of Question 1 wants us to find g prime of 5 using correct units and interpreting our answer in the context of the problem. It is given that g of t equals 90 plus 45 cosine of t squared over 18. Then we find the derivative of this, which is g prime of t, which equals 45 times negative sine of t squared over 18 times t over 9. Then we plug in the 5 because it's asking for g prime of 5. This equals 45 times negative sine of 25 over 18 times 5 over 9, which gives us the answer of negative 24.587 tons. Now for the interpretation. This number represents the rate in which gravel is arriving by decreasing by 24.587 tons per hour at time equals 5 hours. Then we move on to part B. This problem is asking us to find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. This pretty much means we just need to find the integral of this problem, which is the integral from 0 to 8 of g of t d of t, which then means it's the integral of 0 to 8 of 90 plus 45 cosine of t squared over 18. And since this is a calculator active problem, we can plug that into the calculator, and that would give us 825.551 tons. Then we move on to part C. This is asking for, is the amount of unprocessed gravel at the plant increasing or decreasing at the time t equals 5 hours? Show the work that leads to your answer. In the beginning of the problem, it says the plant processes gravel at a constant rate of 100 tons per hour. So first we need to find when t is 5, what does that equal? We plug it in as g of 5 equals 90 plus 45 cosine of 25 over 18. That gives us 98.141 tons. Now we can see that that is less than the 100 tons, which is the constant rate per hour. So in conclusion, when t equals 5 hours, the rate in which the unprocessed gravel is arriving is less than the rate of the gravel being processed. Therefore, the amount of unprocessed gravel is decreasing. Now we can move on to part D. It is asking, what is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? Justify your answer. So we need to find the amount of unprocessed gravel at time t, which is given by f of t equals 500 plus the integral from 0 to t of g of s minus 100 d of s. Now the derivative of f of t, which is f prime of t, would just equal g of t minus 100. Now, when we set that equation equal to 0, we can find the critical numbers. So we will find the zeros by using our calculator. You could graph it or just find zeros. And the 0 that comes out in the integral from 0 to 8 would be 4.9235. Now we need to put them in a table and test them out. So the values we will use is 0, 4.9235, and 8. We plugged each one of those into the equation, and we got 500 for 0, 635.3761 for 4.9235, and we got 5 525.5511 for 8. As we can see that this number is much greater than the other two, showing us that the maximum amount of unprocessed gravel at the plant during the workday hours was 635.376 tons when time T equals 4.9235 hours.